Atlantic Water webinar series. It's our pleasure to introduce James Hale, Matthew Rodi, and Wesley Thu as our presenters today. They will discuss strategies around the appropriate stages of an infrastructure assets lifecycle, as well as demonstrate how combining a clear process with advanced technology can establish a central information hub that optimizes design, construction, and operation of a facility for long-term data accessibility beyond the scope of a project. I am Heather Dean, your hostess. During this meeting, you will be in listen-only mode. We invite you to submit questions at any time during the presentation. If you're joining via computer or your mobile device, you can do so by selecting the Q&A icon in the top panel of your screen. Your questions will be addressed following the presentation. And with that, Matthew, I will kick it over to you to get us started.
Thank you, Heather. Welcome, everybody. As Heather mentioned, today we will be exploring connecting the data of assets to the asset lifecycle, as well as how collecting and using this data can improve overall management and decision-making throughout the life of assets. Here's a quick overview of what we'll be covering today. First, I will discuss how assets fit into the larger picture of city infrastructure, how these assets are built, and then go through the four main stages of the asset lifecycle. Next, Wes and I will look at how a strong foundation in program management and construction management, PMCM, helps to build these assets through large-scale programs. We'll also examine the people, processes, and tools used for managing these programs. Then Wes will explore how these systems and data are set up at the beginning of the life cycle, enabling the data to be utilized throughout all phases. Finally, James will cover how asset management systems are set up to track and manage the built assets, transitioning from the design and build phases to operate and maintain. And then James will show how the asset management system can be used for routine maintenance and tracking of assets, as well as be a decision-making tool for future city planning and preventative maintenance programs. Before we dive in, let's start with an overview of the asset management lifecycle that we will be exploring throughout this webinar. This graphic shows the asset at the center with the four phases of the life cycle around it: design, build, operate, and maintain. On the outside, we see some example work tasks that are required to manage assets over their lifetime. While this is not a full list of tasks, it gives an idea of some of the key functions needed, such as planning, project management, inventory management that is required. And we'll be referring back to this graphic throughout this presentation to illustrate how each section fits into the overall life cycle. In this first section, we will be reviewing how and why assets are built as parts of bigger infrastructure systems, as well as the stages of the life cycle. One note for clarification: when we're discussing design and build, it's in reference to the stages of the life cycle and not related to the design build project delivery method. Okay, let's get started by understanding how assets fit into this larger infrastructure and how assets are built. All right, to get us started, I have a quick survey question to get for everyone to get an idea of who's attending today. We see some example assets and infrastructure systems up on the slide. Give a thumbs up if you see an asset listed here that you're currently working on, an asset or an infrastructure system. Again, just to get an idea of who's here. I see a lot of people working with assets. That's good. In this presentation, when we're talking about assets, these are the types of examples that we'll be talking about. Assets can often be thought of as the parts of larger systems that make up the cities and communities around us. They work together to build the transportation networks, the water management systems, the electrical grids, and the buildings around us. Later on, we'll see how understanding these assets as parts of larger infrastructure systems will help us to understand how to manage these assets collectively throughout their life cycle as well. As I'm sure a lot of you are aware, assets that make up these systems that we just looked at are built oftentimes through infrastructure programs. These are comprehensive initiatives designed to construct, enhance, and maintain public assets. These programs involve multiple coordinated projects that collectively contribute to the development of these systems. There are many reasons these programs are implemented in cities and communities. First, community improvement and economic development. These programs aim to stimulate local economies, revitalize neighborhoods, create job opportunities, and improve the overall quality of life for residents. You can see an example here of a program implemented by the city of Baton Rouge for community enhancement in an effort to repair and upgrade local infrastructure. A second reason for these infrastructure programs is to address environmental, health, and regulatory needs. This includes enhancing public safety and health, ensuring compliance with regulations and standards, and promoting environmental sustainability. An example of a program implemented for this reason would be a city that is upgrading its wastewater treatment facilities to comply with new regulations, an EPA consent decree, some type of mandate that is put out there to go and improve the infrastructure. A final big reason for these infrastructure programs is to manage and replace aging infrastructure as well as plan for the future. This involves maintaining and upgrading existing infrastructure, incorporating technological advancements, and preparing for future demands. An example like this would be a city that is implementing a program to build resilience into their electrical infrastructure by upgrading the power grid to withstand severe storms, as well as possibly integrating new renewable energy resources, planning for future population and growth. By understanding these reasons behind their programs, we can better appreciate the scope and their importance. And this foundation will guide us as we dive into how the assets are managed throughout their life cycle. Let's now start looking at the phases in the life cycle, and we will start with the first phase, which is design. Within this design phase, we're focusing on several key activities. One is planning, which involves developing the overall strategy and approach for the project. Second, creating detailed specifications, which defines the technical and functional requirements of the project. Then securing right-of-way by acquiring the necessary land or property rights. Also coordinating with utilities to make sure utilities are relocated as needed, as well as obtaining any permits needed for approval. During this phase, we're collecting important data for our asset, such as project scope, cost estimates, GIS data, material specifications, and which will set the foundation for the next phases of build, operate, and maintain. Next, let's move on to the second phase of the asset lifecycle, build. The build phase is where the actual construction takes place, turning design plans into physical assets. This phase is critical for ensuring that the project is constructed according to the specifications and requirements established during the design phase. Within the build phase, some key activities include the project execution, which involves carrying out construction activities as planned, managing the schedule and cost, which ensures the project stays on time and within budget, and inspection and quality control, which verify that all work meets the required standards. During construction, we continue to collect essential data such as progress reports, material usage, and as-built drawings to capture any on-site modifications. This data helps to execute the construction efficiently and sets the solid foundation once transitioning to the operate and maintain phases. And finally, let's look at the last two phases of the asset life cycle together, operate and maintain. These phases happen together after construction is complete and the asset is ready to be used. They are crucial for ensuring the long-term functionality and efficiency of the asset, which ultimately reduce the cost and enhance the service delivery through the asset lifespan. Operate involves the daily management and use of the asset, ensuring operational efficiency and effectiveness. Maintain includes regular upkeep and servicing to prolong the asset's lifespan, as well as preventative maintenance to avoid breakdowns and costly repairs. During the operate and maintain phases, we continue to collect various types of data, including operational performance metrics, maintenance logs, and incidents reports, which this data helps to track the asset's condition, identify potential issues early, and plan for future maintenance activities. The data collected once assets are built also flows back to the beginning of the life cycle when planning and designing the next program and assets to build. All right. Now that we've covered the basics of assets and the asset life cycle, let's focus on the left side of this asset life cycle wheel that we looked at the beginning, and how a foundation in program management and construction management can help in this design and build phases. Okay, another brief survey to give a sense of the audience. How many of you are involved in managing an infrastructure program? How many of these assets that we looked at before are part of a program that you're managing, or in any role? Yeah, I see a lot of you managing programs as well. That's great. So in this section, we'll be looking at how program management, construction management can further improve those programs. So what is PMCM? At a high level, PMCM is a structured approach to managing and delivering multiple assets efficiently. PMCM provides the coordination needed to ensure that all projects are aligned and effectively managed to meet their strategic goals. Without a structured approach, managing these projects can often become chaotic and inefficient. So what's kind of the difference in PM and CM? Program management to PM have. The goal is to align all of the projects within a program to achieve the broader strategic objectives. This involves overseeing project interdependencies, allocating resources strategically across projects, and maintaining consistent quality standards. The benefits of a strong PM foundation include increased efficiency, consistency, and oversight across the entire program. Construction management, the CM, on the other hand, is the process of managing the individual projects of the program from inception to completion. Key tasks here include coordinating contractors and subcontractors, managing procurement and logistics, and ensuring adherence to project timelines and budgets. Effective construction management ensures that projects are completed on time, within budget, and to the required scope and quality standards, thereby contributing to the overall success of the program. This PMCM approach helps to ensure that all aspects of the program and projects are well coordinated, efficiently managed, and aligned with the strategic goals of the organization. Now let's look at some of the specific functions within program management and construction management that contribute to this comprehensive approach. To successfully implement PMCM for these large-scale programs, we can see there's numerous functions and tasks that need to be completed. We see here some examples, again, of what these functions are that are important, such as standards development, risk and change management, and program reporting. We won't dive into specifics of how these tasks are done, but they illustrate the wide range of tasks that need to be considered when initiating a program, highlighting complexity, potential challenges of maintaining a program. At the beginning, you have to figure out a plan to accomplish all of these types of functions. With Stantec and program management, we have the experience and the personnel to understand these types of functions and how to run them efficiently and effectively. So now we'll discuss how these functions kind of fit into Stantec's overall program management approach. Okay, now we know a successful program needs more than just a collection of projects and management tasks and functions that need to be completed. So Stantec takes a comprehensive approach to managing the program, regardless of what type of program it is or what tasks need to be completed. So this approach includes three main areas that guide our work: plan, deliver, communicate. Plan involves the initial program mobilization, benchmarking, and making ongoing refinements during delivery. This area includes defining which tasks need to be done and how they should be completed. Delivery encompasses overall program management, individual project management, project delivery, and control of scope, cost, schedule, and quality. This is the area where the technical work of the program is being completed. Finally, communicate includes both internal and external communications, such as progress reporting and outreach among various stakeholders, such as clients and the people living in the communities. This communication supports effective decision-making and helps to secure stakeholder support. You will also notice the arrows flowing between each of these areas. These three areas are deeply interrelated and feed into one another. For example, we start with an initial plan, which is codified in the program management plan to guide delivery. As a project delivery commences, progress is communicated to stakeholders through reports and updates. And based on any feedback and findings, any necessary adjustments to the delivery are made, which then lead to refinements of the baseline plan and overall delivery strategy. This cycle of planning, delivering, and communicating promotes continuous improvement and effective program management. It also improves the value of the data that we are collecting during the design and build phases of the asset lifecycle. All right, and now I'll hand it over to Wes, who will dive deeper into the Stantec PMCM framework and setting up the systems to begin collecting asset data. Wes?
So in PMCM, our approach to program management really revolves around our three main success factors, which are our people, our processes, and our systems and tools. And when we can deliver on these three factors, we increase the probability of delivering a successful asset. At the end of the day, the combination of these three assets working in sync drives both financial and operational efficiency for our client. Our PMCM team has found great success with this approach on some of our programs, such as the Made Up Blue Level Battery Park in Marshall, Michigan, and our Move BR program in Baton Rouge, Louisiana. Our programs are only going to be as good as the people we build our team with, and this includes a multitude of various roles stemming from our program managers to our program controls, to our technical experts, and our PMIS implementation teams. It's this pool of knowledge and expertise paired with our collaborative focus is what allows us to support our clients with value-added services. Processes play a large role in taking an asset from design and build stages and allowing it to mature through the operate and maintain stages of a program. Building a process starts with having a good scope understanding. And this involves collaborating with our clients to understand their needs and how we can effectively manage their schedule and cost. And many times these needs change over the life cycle of an asset, which requires us to constantly adapt and innovate. With our experienced implementation teams, we're able to provide benefits such as improved project coordination, improved risk management, and also quality assurance for our work. And in combination with our PMIS systems, which we'll dive into a little later in the presentation, we're able to generate process and asset data, which creates data-driven insights, which we can then use to track the development of the asset over time. And then we can take those insights and communicate our program performance with our client and program teams. As we just touched on our systems and tools, they're really the basis of how assets are designed and built. And they allow us to create centralized locations to store our asset data and take them from design to construction. In this visual, we demonstrate the number of systems and tools that our program management team has at its disposal. Our team has in-depth knowledge and experience with systems such as eBuilder, Kahua, Procore, We can deploy advanced SharePoint sites with Power Automate and Power BI features. Essentially, if there's a system out there which we feel can bring added value, we make it a point to become experts in that system. And the great thing is each system is unique, and it allows us to advise and select which systems provide the most value add to our client specific needs. At the end of the day, our people, processes, and tools must all work in sync to deliver a successful asset. It starts with our procedures. What workflows will we need? What reports will the team need? How do we manage our schedule, and so on? And secondly, we identify which tools will best serve our needs. We then use these tools to collaborate and communicate with each other, which also allows us to generate reports with valuable KPIs for team distribution. And our end goal is to use these aspects of program management to create transparency between our program team, our client, and the systems we collaborate on, with the hope that it also fosters accountability amongst all stakeholders. Next, we'll talk about connecting the data lifecycle, still within the design and build stages of the asset lifecycle. And you can see in the visual here, the hope is that as an asset matures over its life cycle, the data that's produced and stored also increases over time. And this is the benefit of using our data systems to create a connected data environment between the design and build stages over to the operate and maintain stages of the asset lifecycle. So what kind of data are we able to collect? Well, the possibilities are really endless. However, some of our most common types of data include cost and schedule data, GIS data, contractual data, and review and approval data from our system workflows. Cost data allows us to track expenditures against our original budget estimates, which allows our program controls to advise critical decisions along the asset lifecycle. And we can determine any variances between actual and estimated spend and make adjustments to our cost allocations on the fly. Now, schedule data tracks deliverables against project timelines, and it provides real-time updates on project progress. This allows us to keep our project on schedule, as well as identify any critical path activities that may impact project development timelines in the future. Our GIS data consists of items such as location mapping, spatial analysis, and any environmental impact data points. And our PMIS systems allow us to store this data and prepare it for when our assets transition to operate and maintain stages. When it comes to contractual data, our PMIS systems have the capabilities of not only storing our executed files, but also tracking contract status as it moves through each reviewer during the negotiation stages. This allows us to ensure that contracts and change orders move through the system without bottlenecks. Additionally, our system permissions allow us to restrict contractual and confidential information to program leadership. Here you can see some of the workflow capability that we have with our PMIS systems. We're able to streamline processes for our clients and program teams, all to drive project efficiency. And depending on the program needs, our capabilities are endless. On programs such as our Sandy Clean Water program in Sandy, Oregon, and in our Pure Water program in San Diego, California, we've been able to develop streamlined invoicing workflows through Power Automate and SharePoint for ease of submission and review. On other programs such as MoveVR and Blue Oval, we've developed workflows to manage contracts all the way from negotiation stage through the execution stage. And as I touched on our last slide, our PMI systems are able to track and review approval history for all workflows, not just contracts. And that allows our technical staff to stay on top of items such as RFI, submittals, inspections, and so on. Every review comment is recorded, timestamped, and filed for future reference. And this comes in handy when our technical experts are dealing with items such as RFI and submittals and these items that may have many versions depending on the situation. And these PMIS systems also provide the capability of generating vast document repositories for all stakeholders to work on. And this creates a single source of truth as we're able to manage version control and access control to ensure that our assets are secure. At the end of the day, the data is only valuable if we can utilize and convey it in a way that makes sense to both our program teams and our clients. And when we manipulate the data to create real-time project insights, we provide that extra value add, which helps everyone involved. We have the capabilities of creating tailored reports, customizable to the needs of our own team or the client. The data is real-time, and we can set it up for automated distribution, whether it's on a daily, weekly, or monthly basis. Yeah. And as we complete the design and build stages of the asset lifecycle, our systems have the capability to package the data we've collected in preparation for transfer to the asset management team. And I'll now pass it off to James, who will talk about creating the system of record.
Thank you, Wesley. Thank you for birthing an asset. We're now at the stage of creating the system of record. That is our asset. We're now ready to get into asset management. As you know, the very first step in asset management is creating the asset inventory or documenting what assets you own. Can I get a show of thumbs up? Who all is working within an asset management framework right now? Good. Seeing several thumbs up there. Looks like the majority of you are working within an asset management framework. One thing we're learning is that the information involved, the data for the asset matures or becomes more valuable over time. And we're going to prove where we get into the operate and maintain stage where that the value of that asset information really can help us. Okay, and then because we're in a digital project delivery, we've now have a fully connected data environment. You can see we started birthing the asset in the digital project delivery, and finally we're now getting into the enterprise asset management. What we're talking about in this presentation here is the connected data environment. In this example, we're talking about GIS. GIS serves as that connected data environment. Okay, so the system of record remains in the GIS. This is a GIS-centric approach. What we're talking about here is that any asset, if you maintain an asset, that has a record in GIS. And GIS contains valuable information. It's the physical information about the asset. It contains reference information. Where is that asset located? What zone is it in? What pressure zone is it in? What's the hierarchy of that asset? What's the current condition? And perhaps even some asset management fields. That's the source of truth. The system of record is the GIS, the geodatabase, right there in the center. If we look down at the right there, the asset condition, well, it may also have a source of record. You might be using Esri field maps for collecting condition information. You might have a CCTV program where that's your source of truth for the current condition of that asset. Very important, though, to write that information right back to the GIS. So again, you keep all of that information in one location, no matter what system you're using to collect that information. Very important not to silo it. Probably the number one offender of siloed information can be CCTV programs. We find oftentimes these vans and trucks house this information. It helps maybe remove a blockage at the time of videoing and then videoing again and make sure that blockage is gone. But what you're missing there, if you silo that information, is the condition of that pipe. Is it failing? Is there overflow coming into it? All of that's important to bring it back to the system of record. Why? The system of record can support the system of engagement, help create your preventive maintenance plans. This is your CMMS right there in the middle. What's the maintenance history? What kind of failures are you having? What's the cost of owning that asset? And finally, over to the left, we have our system of insights. These are dashboards ArcGIS dashboards, Power BI. This is where you're reporting the health of your asset system or assets, the health of those assets to the decision makers, those that are able to fund improvements. Let's take a look at a typical ArcGIS water data model. Here we've got the physical information, just getting a view of it. The pipe type, that's your asset class there. Diameter, material, all that information, very important. Who owns the asset? A lot of this, as Matthew and Wesley were showing, is created in the design build stage. You can have linkages to shop drawings, to any type of as-built information to get even more detailed information on that asset, all within your GIS. And take a look at even some more detail at some of these attributes as they're being captured. Okay, and now we've got the life cycle and risk information. These are fields that Stantec typically will add to our client's database, the GIS. You can see the design life. And we'll blow that up, even the life cycle status in there. The current condition rating, as we saw in the previous slide, we recommend pushing that data back into the GIS, maintaining that data within the GIS for all your assets. When was that condition taken? Was it taken last month? Was it taken 5 years ago? How relevant is that condition rating? How much useful life is left in that asset? You know, we know the design life, but based on the condition rating, how much useful life is left? When should you plan to replace it? And finally, our three asset management fields: the likelihood of failure, consequence of failure, and then the business risk exposure, which is a multiplier of those two metrics. Okay, so now that we've built our asset record, we've got our asset inventory, we've got the right fields in there to maintain it, we've got our processes set to bring data back in from peripheral systems that are collecting condition information. Now we're ready to operate and maintain the asset. At this point in the life cycle, we're looking at implementing a CMMS. Here's a look at CityWorks here. This is a work order template for a water main break. And as you can see, there's some customized fields that we've created here that really capture not only they're confirming certain information, they're confirming physical information. If we blow that up a little bit, we can see that we're capturing material, diameter, but what's the root cause? Not all breaks are the same. You know, oftentimes we'll work with a client and we'll ask for, do you have your break information? And we'll get a data set that has all of the breaks that have ever happened, but they don't say why they broke. A break that happened from a material deterioration is significantly different than a break that happened from a third-party contractor hitting that asset. Both of them have different predictions for how an asset may fail and really predicting how other assets similar to them may fail. Very important to collect that detailed information on how your maintenance, how your reactive maintenance, what's the root cause of asset failure. Why is that important? You know, we said that enriching data over time we get much more value over it at this stage. Here's an example where we had throughout, this happened in South Florida, we had a sewer pressurized main system where there was a catastrophic failure. But what happened, you know, we were doing an asset management project, things got prioritized, other projects got prioritized, and this effort was put on hold temporarily. Well, during that hold, there was a catastrophic main break. And one of the things they want to look at is, well, where did we predict that failure would occur? Well, we predicted failure would occur based on attribute correlation here. You can see we used a regression analysis to predict the total pressurized system had about 15% of all the pipes, they had condition assessments done on it. So leaving 85% of the pipes without a condition assessment. Using this regression analysis, we were able to predict the remaining 85% using asset correlation, and which accurately predicted the number one offending pipe, the riskiest pipe in their system, had a failure, as you can see here. Over 300,000 gallons of raw sewage spewed into a residential neighborhood. It made front page news for several days, and it was quite an embarrassment to the utility. The bad news is the incident happened. The good news is the utility really learned the value of that physical information, of capturing really good water main break information. That information there would be able to predict future spillages or catastrophic asset failure. So again, we're proving the value of this asset information over time. Another good use of collecting detailed root cause analysis information is being able to figure out where and why your assets are failing. Are you having material deterioration because you used a type of fitting in the 90s, and now you're looking at all your pipes in the 90s are typically in this past decade are starting to fail because of fitting material deterioration? Are you seeing corrosion? You're seeing your ductile iron pipes from the 1940s and 50s are starting to commonly fail. Are you getting hot spots? All this information is valuable in informing your predictive maintenance plans, your repair, your replacement programs. Looking at collecting that data in automated ways. Here's an example up in Michigan where we've configured a solution where our client's going out and exercising their valves. Well, the torque that the valve takes to turn is now being translated into a condition, and that information is being pushed right back into CityWorks and then subsequently back into GIS, so they know the current condition of all their valves through an automated data stream. And not all criteria are the same. Here's an example where setting up the asset management framework, we're looking at every asset uniquely. For this example, we have very little representative condition of the current condition of the pipe. Because of that, we have to look at other attributes that might predict failure. Again, this is an example where we're meeting our client where they're at. This client had less data that represented the current condition, but because of that, we're able to tap into other types of data that will help predict the likelihood of failure. For other assets where they have very good data, in this example of this client, they had very good air release valve data, current condition. Well, that likelihood of failure criteria weighting you can see there was more like 70%. So it depends on the asset. It depends on how much data you have to set up these likelihood of failure criteria and weight them appropriately. And data integration. Here's an example of CCTV data coming back. There's standards across the U.S. for how the current condition of a pipe can be. Well, the condition of a pipe in Arizona is not necessarily the same as the condition of a pipe in South Florida. South Florida is much more wetter soil. So some of the failure or some of the observations that have to do with moisture infiltration are much more important in Florida to determine what's the condition of that pipe or what's the likelihood of failure to not meet a level of service. In this case, it's keeping water out of the gravity system. And what does that look like? Here's an example of an adaptive asset management plan. You can see we've got likelihood of failure. We've got the BRE all calculated in the left panels here in this digital dashboard. More importantly here, we can zoom into certain areas, draw projects, and calculate what's the reduction of risk that this project would have. We can start comparing various projects and figuring out which one adds more value to reduce risk in the system. This is an example of very mature data, very valuable data, longer or further along in the asset wheel that Matthew and Wesley were showing. We've now got very valuable data to help predict how we're going to spend our resources to keep our system less risky. And what do we do with this information? Well, we've seen in this part of the wheel we're nearing the end here. We've got two decisions we can make. We either, when an asset's high enough consequence of failure, high enough likelihood of failure, and the subsequent risk is high enough, we've got two decisions to make. Do we perform increased preventative maintenance program on that asset, or is it time to start the asset lifecycle wheel over again and perhaps do some capital planning? So you can see we've gone through the full life cycle here of design, build, operate, maintain for those assets that have hit their end of useful life before catastrophic failure occurs. We're ready to get right back into the planning stage and let Matthew and Wesley take over with their design build programs. Well, thank you for listening to our presentation. Any questions?
Thanks, James.
Thank you.
Thank you, Matthew. Thanks, Wesley. And thanks, James, for sharing with us how to capture the right information at the right time during the life cycle of an asset. It's fantastic information. We have a number of good questions here already, and I encourage you, our listeners, to keep those questions coming. And again, you go by selecting the Q&A icon on the top panel of your screen. First question in. James, this is to you. How does an organization begin to link design and build to operate and maintain?
A great question. And as you can see, we showed a connected data environment. So what we really encourage is, number one, having standards in place during the design build stage. These standards should lend themselves to having a digital delivery environment. So for the example of a water system, capturing that data in an AutoCAD format as it's being designed, with the end in mind that AutoCAD file is going to make it to GIS, capturing some of those attributes early on and layering it in the proper standard that's going to translate well into GIS. So I would, a short answer, GIS is a heck of a connected data environment to get from that design build to the operate and maintain. Great question.
And James, continuing off that question and response, there's another question that came in. Would you harness the power of GIS to also manage vertical infrastructure, or keep that in the CMM as to establish appropriate system hierarchy?
Oh, that's another great question. Vertical infrastructure can be somewhat intuitive if you know where to map and where to stop mapping. For instance, a water plant, sometimes mapping down to the sub-process level and then from there going into a tabular hierarchy can be intuitive enough where you would want to keep it in GIS. But what we're finding is with advances in technology, BIM and ArcGIS indoors can actually be very great ways to capture that vertical information, keep it in GIS, and utilizing that directly in your CMMS. So I would say in the next few years, you're going to start seeing a lot of utilities utilize BIM, bring in BIM right into GIS. ArcGIS reads Revit files natively, so building that system of record in a BIM environment, bringing that into GIS, and then managing that in GIS, also utilizing that Revit file for continued design build information. You have your full connected data environment there.
Thanks, Pat James. Question, Wesley, what tools do we have experience with for PMIS? And is the PMCM team set on just one tool?
Thanks, Heather. We have experience with systems like eBuilder, Procore, PMWeb, Kahua. I could really go on. SharePoint, P6, all of these things. And to answer your second question, no, we're definitely not set on one tool. We're very software agnostic. We generally recommend the tool that will be the best fit for the program after we do our initial, our initial findings. So yeah, we're open to many, and we're always learning too. So if there's anything new that's out there, we get our team together and try and learn it as best we can.
Great, thanks. And piling on from that, how long does an implementation for a PMIS take?
That really is determined by the scope of the project and the size of the project and what the requirements from the client are. So, I mean, we've done things on a really quick turnaround, maybe 1 or 2 months. But then, if there are multiple stages in different parts of a program that we need to work on, then it could be a few more months than that. So it all depends on what the client approaches us with.
Okay, thanks, Wesley. How does Stantec help manage risks associated with large-scale infrastructure projects?
I can hop in here. So, a large scale infrastructure project we're talking about, you've got lots of stakeholders in there. Some of the risk can be minimized by really bringing in your stakeholders, your cities, your counties. The more folks you bring to the table, the more perspective you're going to get, and really help minimize some of the risk with that larger infrastructure project. Hopefully that answered the question. I would say the more you bring to the table, the more stakeholders, typically the larger the project, better communication, better planning, having stakeholder meetings very ongoing, minimize the unexpected consequences that may occur throughout the project, bringing everyone to the table.
Yeah, I'll add on to that, James. Thank you.
Sure.
The risk management, it starts a lot at the beginning of the project and the program. It's collecting that data, and once we have that data, that becomes more valuable over time. And so we're able to kind of minimize risk by having the right data in the right places that we've collected through the program.
Great, thank you both. Another question just popped up. James, how does my organization begin to collect data during the operate phase?
Well, that's through your CMMS. You're going to want to have a CMMS implemented. And, I always recommend a GIS-centric CMMS, something where you can visualize the assets. You know where your assets are. They're highly connected to your GIS program. The CMMS is going to record your maintenance, your reactive maintenance, help plan your preventive maintenance, or record where your preventive maintenance is occurring. That's what you want. I mean, that's imperative at the operate stage, is to implement a CMMS that's either directly linked or highly integrated with your GIS. Great question.
Thanks, James. Let's see if any more questions here trickling in. All right, I'm going to throw this out to the team. And maybe Matthew, you might be the correct individual to respond to this one. We use eBuilder, and it seems that the out-of-box reporting is for the project's life. We operate on a fiscal year basis. Have you run into this issue using PM systems?
Thank you. Yeah, a lot of the out-of-the-box reporting in eBuilder comes standardized, and through the implementation, we can customize those reports so that the time frame of the reporting can match a fiscal year. It can match a monthly basis, any kind of time frame that we're looking for. So that's kind of a customization once the implementation is in progress.
Great. Thanks for that. And I do not see any more questions in the chat unless there's any last final coming through here. Otherwise, we will wrap it up for the day.
You know,
Yes, James.
Jenny, if I could add one more, sort of expand on the answer about the risk, large scale, how to minimize risk to large scale infrastructure projects. One thing our asset management team preaches is operational readiness. That sort of relates to what Matthew was saying, but operational readiness is, knowing what assets you have, having your maintenance plans already in place before the asset comes on board. There's so much you can do before that asset becomes live. Having your SOPs, having the training, having everything prepared before the operation, before the asset goes into operation. Just wanted to expand on that answer a little bit.
Yeah, it's a very good point, James, and we can definitely help our clients with that as well. All right, so with that, we're going to wrap it up today. Thank you to our presenters, and thank you all for your participation. If you have any other questions for James, Matthew, or Wesley, their contact info is located in the chat. You will receive an email shortly with your participation certificate, and we will also be posting this presentation on stantec.com if you'd like to listen again or share with a colleague. Our next presentation will be on Wednesday, September 18th, where our panel will be talking about getting the most out of your water storage tanks. We hope you can join us again soon. Thanks all.